students, this is how it starts here for your build an atom activity. You want to click on in the middle here, the orange run in HTML5. Once you click on that, it's going to open up to this page here. You want to click on the left one here, atom. Now, once you're in this screen here, you can see it has protons, neutrons, electrons. This will tell you the number. The element over here, this will move as you manipulate this simulation. You want to open up the net charge as well as the mass number. And I like to also click on the stable/unstable. Now, what you're going to do is you're going to start adding in different subatomic particles. So you add in protons. Obviously, a couple things change here. The net charge, mass number, you can see this is now helium. And you can also add neutrons and maybe an electron. And again, all these things here are starting to change. When you are manipulating this here, this is how you want to answer those questions. You want to continuously play around with this simulation until you can make definite rules as to how to answer some of those questions. So how do you change the actual element? You need to add a blank or whatever it would be. Now, when you get done with this here, the very last page is going to tell you to click on this symbol tab at the bottom. It's going to be a similar thing, but this time it has the symbol here. This symbol is associated with the boxes up here on the periodic table. Again, you want to click the stable, unstable box, and then once again, you can manipulate this as well. The key is you need to continuously play around with this so you can see what changes over here as you add different subatomic particles. This will help you when you take your quiz. Eventually the quiz, you will click on this game down here, and you can play with this before you take the official quiz as well, but all those things you just did on that simulation will be used within this quiz here. Have fun with the activity. In this video, you're going to learn how to determine the number of neutrons. One tool you will have is a periodic table. Remember, on your periodic table, it has all the information you need. Here's neon. Let's zoom in. Each periodic table must have the atomic number, the element symbol, element name, and the atomic mass. Now, the atomic number is the number of protons, and the atomic mass is protons plus neutrons. Once you know the atomic mass, you simply have to round it to the nearest whole number. In this case, 20.18 would round down to 20. Now all you have to do is a simple math problem. 10 is the number of protons, so you take 20 minus 10 equals 10 neutrons. Neon, protons equal 10, neutrons equal 10, electrons equal 10. Hello students, this is Mr. Schaefer. As promised, I'm going to go over the 4 perfect steps to draw a Bohr model. Once you successfully complete these steps, we will then get out the special markers and we will be able to work with this with a partner or a small group to make sure that you understand how to create a perfect Bohr model. Students, now you have 2 documents with you. The first document you have is simply your periodic table. The other document you should be looking at is the word cloud. We'll talk a little bit more about that in a second. Within that periodic table, you now know that the row across is going to equal step number 2, which is determining how many shells you must create. If you look at the 4 perfect steps, step number 1 is to create the nucleus. Step number 2 is to determine the number of shells. Step number 3 is to determine the number of electrons. And step number 4 is to apply those electrons to the correct shells. If you look at the Wordle, that not only has all of the important vocabulary for this unit, but it also has clues to those 4 perfect steps. Have a great time creating those perfect Bohr models. Second element we're going to do is neon. Same thing, first step, fill in the nucleus. Atomic number's 10, 20.18 rounds down to 20. 20 minus 10 tells me I have 10. It is also in the second row. Therefore, I'm going to have 2 of these shells. And I know I need to have 10 protons, 10 electrons. So now I have to place it on there. 1, 2, 3, 4, 5, 6,
7, 8, 9, 10. So if you look over here, neon is in the 8th row, which means you should have 8 in its last shell. 1, 2, 3, 4, 5, 6, 7, 8. 10 overall, 9, 10. That is how you do a bore model.